Alright guys, welcome to this page of the notes, and here's what we're going to do. Those problems we just looked at that are really kind of ugly at the start. Well, it turns out that I can give you something exactly like that by giving you ordered pairs that represent a slope but have a variable in them that I want you to solve for. So this is going to be solving problems using the slope formula for m. And in the problems, right, you're going to wind up with complex fractions, complex rational expressions, and that you'll need to solve for that variable. Let me show you what it looks like. Again, you'll recognize it from what we just did on the previous page. Let me show you how this first one sets up. I give you two ordered pairs, the point A and the point B. These are ordered pairs. Right? I tell you that, right? Find the slope of the line that passes through these points. What is the slope of the line? All right, great. x1, y1, x2, y2. Now, why do I label them x1, y1, x2, y2? Well, you guys know the slope formula. The slope formula is m is equal to y2 minus y1 over x2 minus x1. And I think at this point, probably many of you see what's coming. y2 is a rational expression, 3p, 3 over p, minus y1, which is 1/2. That's all divided by x2, 1/3. Minus x1, which is 2 over p. Guys, you should recognize this. It's kind of that ugly thing that we looked at before. Maybe this one's got more numbers in it than the previous ones, but it is the exact same thing. I have fractions in the top that I'm subtracting. I have fractions in the bottom that I'm subtracting. I need to find a common denominator. It's really easy, right? It's p and 2. So the LCM is 2p. In the bottom, it's 3 and p, so the LCM will be 3p, right? It's pretty simple and straightforward like the previous ones. It's just the problems, there's a process that you've got to go through. So let's follow that same process that we did before. Here we go. You wind up with 3p times 2 over 2 minus 1/2 times p over p. In the bottom, 1/3 times p over p minus 2 over p times 3 over 3. What that's going to do is give me a common denominator of 2p, and then in the bottom, a common denominator of 3p and 3p. That way I'll be able to subtract the fractions in the top, subtract the fractions in the denominator. Here we go. This gets me 3 times 2 is 6 all over 2p minus p all over 2p. In the bottom, I wind up with p all over 3p minus, again, 6 all over 3p. Okay, well, I've got my common denominators, right? Common denominators, 2p, so I can subtract the fractions in the top, subtract the fractions in the bottom. 6 minus p all over 2p. That's all divided by p minus 6 all over 3p. And again, just like we saw in the previous example problems, I go and take care of the fractions at the top, take care of the fractions at the bottom, and I wind up with a complex rational expression. Keep the top, multiply by the inverse of the bottom. I'll write it right here so you can see it. 6 minus p over 2p multiplied by 3p all over p minus 6. P's cancel, top and bottom. Here's what I am then left with. Let me slide up so you can see where I'm at. That leaves me with 3 times 6 minus p and 2 times p minus 6. Hang on a second. We've seen this before as well. Positive 6, negative p. Positive p, negative 6. Those are almost the same. They're so close except for the signs. pull out a negative. I'll pull a negative out of the one in the top. That's going to leave me with a p minus 6. In the bottom, 2 over p minus 6. Cuckoo, ka-choo. P minus 6's cancel top and bottom. And guess what you just did? Yep, you just found the slope of the line that passes through those 2 points. Remember, right, way up here at the beginning, it was m. M equals, well, m is the slope. So way back down here at the bottom, there it is, m equals, what is the slope? The slope is negative 3/2. And you were able to do it by evaluating a complex rational expression and canceling GCFs as they show up. There's a couple more example problems there for you to go ahead and try again, but this is the 4th time we've done a problem like this. I think at this point you probably have gotten the hang of it. I had a great time looking at adding and subtracting rational expressions with you. I hope you enjoyed it too, and I can't wait to see you next time. Bye.